Hello, everyone, and thank you for joining us today for this webinar entitled The Secret to Lowering Production Cost in Composite Molding. It is brought to you by JEC Group and presented by Elkem Silicones, one of the leading companies in the production of silicone materials. My name is Benjamin Debucher, and I'm Program Manager for JEC Group. This presentation today is dedicated to composite molders on how to lower their production costs by improving process efficiency using silicone's reusable vacuum bags. It will introduce you to the process of infusion molding with silicone RVBs, its main advantages compared to traditional composite molding methods, as well as giving you some customer data highlighting its impact on the overall process efficiency and cumulative serial production costs. In this webinar, you will learn how to standardize your molding processes, increase your overall productivity, reduce the required man-hour for your molding operations, switch from classical infusions molding to reusable vacuum bag, and set your team up for success with the right material, equipment, and know-how. This presentation will last about 30 minutes, followed by questions and answers. So please feel free to share your question with us by typing them in the question tab on the right of your screen. You have also the possibility to upvote the questions. We will try to answer all questions at the end of the presentation, and if we can't answer your question in live, the speakers will get back to you after the session by email to give you an answer. At some point, we will use also the polls tab so that the speaker can ask you a question and know more about the audience. One advice to maximize the experience of the webinar, I recommend the audience to be connected through cable wire rather than Wi-Fi. This webinar is being recorded, so you will be able to view the entire program online later on jeccomposites.tv. Our presenters today are first Lisbeth LANGSAGER, Global Market Manager for Advanced Molding and Printing at Elkem Silicones. And our second speaker is Mario Pereira Maldonado, Research and Development Analyst for Advanced Molding and Printing at Elkem Silicones. I would like to thank you again for taking the time to be with us today, and I'm now going to hand over to Lisbeth and Mario. Enjoy the presentation.
Thank you, Benjamin. I will also start to present you my colleague, Mario Maldonado. Mario is pursuing a master's degree in materials engineering at Mackenzie Presbyterian University. He has been working for Elkem Silicones for 5 years. He's focused in high-performance silicones. Mario is also the technical contact for molding applications at Elkem Silicones in Latin America.
Thank you, Lisbeth. My co-host today will be Lisbeth LANGSAGER, who is a trained marketing professional from Copenhagen Business School. With more than 20 years of experience in silicones, Lisbeth is the Global Market Manager for molding applications in Elkem Silicones.
Thank you. Before we enter into the core of the webinar, I will give you a brief introduction into the agenda. To start with, we will give you a short introduction to Elkem Silicones. Secondly, we will walk you through Elkem Silicones Reusable Vacuum Bags 101. We will give you an introduction to silicone chemistry and present our silicone range for reusable vacuum bags, together with our partnership with Silicone Composites for machinery, before we close the presentation with a conclusion and a Q&A session. So, Elkem Silicones and composite molding. Who is Elkem? Elkem is a global company. We have production and sales offices in all parts of the world. Elkem Silicones has 75 years of experience of producing silicones for various applications and markets. Elkem has the advantage of being an integrated silicone supplier, which means that we produce all the parts of our raw materials for our production at our own sites, from quartz, where it all starts, to the final formulation of our silicones. We are a global company with close relationship to our customers, and we have a team full of experts who are ready to support our customers and their needs. Elkem Silicones has a proven track record for supplying key industries for decades. We are a long-term supplier to the automotive industry, the aeronautic and aerospace industry, and to the defense, marine, and energy industries. For all of these,
apparently we lost Lisbeth. That's the risk of being live. Just wait just a second. I'm sure that Lisbeth will be back on stage. In the meantime, I would like to launch the poll for you to answer a question to help our speakers to know more about you, and especially about the process of reusable vacuum bags. So I'm going to publish right now the polls that you should have appear in the poll sections. And so you can answer who use or know the process of reusable vacuum bag.
can you hear my?
Yes.
Can you hear me again and see the screen?
Yes, exactly.
Sorry. So technical issues. I'm not sure where you lost me, but I will continue with this slide. What I wanted to tell you here is that concerning room temperature vulcanization with two-component silicones, better known as RTV2 technology, Elkem has been serving customers with this technology in the molding market for 60 years. We have a solid experience in formulation of both polycondensation and polyaddition silicones and their applications. 10 years ago, we started to develop the first products in our range for the composite market, a product range we have extended over the years in collaboration with our customers to meet their application needs, as well as general market needs, with the ambition to become a world leader in this application. In today's webinar, we will focus on solutions for composite molding, the reusable vacuum bags made out of silicones. And I think that you launched the poll, Benjamin?
Yes, indeed, I launched the poll, but again, I asked the audience to answer the questions that we just published in the poll section, so Lisbeth and Mario can better understand who knows reusable vacuum bags from the audience. Thank you for your participation.
Thank you. So while you're answering to our questions, Mario will take you through Silicone RVBs 101, Why and How, Introduction to Reusable Vacuum Bags.
Thank you, Lisbeth. Regarding composite molding, silicone reusable vacuum bags, and I will call them from now on by RVBs only, are the state-of-the-art production method. RVBs are an improvement to the infusion molding process, reducing waste generation, improving the vacuum quality, increasing mold cycling life, and most importantly, drastically reducing the setup time. These silicone molds are specially made to go without any disposables auxiliaries, having the resin and vacuum channels, connector, and lifting clips built in the RVB structure. In addition of cost reduction, this guarantees the positioning and repeatability of the molding. In this webinar, you will hear us talk about two different processes. First, the RVB construction. This is mold fabrication process, and will only occur once in the beginning of the production, and later for mold replacement. Second is the composite part production. This is, in fact, the RVB in use. For this process, the same RVB will be used over and over until the silicone deteriorates after dozens or even hundreds of cycles. RVB's cost reduction is directly dependent on the cycling life. From Elkem's experience in composite molding, different resins will have different impact on the RVB life. going from 50 cycles without any mold deterioration for more aggressive resins, up to 500 cycles for general resins. In an economic point of view, RVBs have a payback turnover around 20 cycles. In other words, composite goods with manufacture of more than 20 molding cycles are suitable and economically more viable when RVB infusion is chosen. Side by side, all these advantages sum up to production cost reduction. This being by disposables cutback, by waste treatment expenses, or even man-hour saving at setup. I believe Lisbeth has fallen, but I'll keep on
Here we go.
my presentation. Okay.
Thank you, Mario.
Perfect. But there's more to look into. Most traditional molding processes are mainly dependent on the skill of the operator. Small errors may cause the whole piece to not be completely infused in the classical infusion, impacting directly on the line productivity. RVB infusion is a more reliable process as the channels and connectors are part of the mold. This avoids processing errors and reduces repair cost. As there is no need to position disposables, the whole setup is a quick process, saving man-hours. After the infusing, all these disposables that are mainly plastic-based parts will be contaminated with resin. According to some regional laws, resin-contaminated waste should be specifically discarded and treated by a specialized external company, generating higher costs. Composite parts are a huge range in the green solutions industry, such as electric vehicles, wind power, or public transportation. RVBs perform in a more sustainable way. By closing the resin chamber, infusion process inhibits the volatiles to reach atmosphere. By reducing waste generation through disposables consumption and longer-lasting molds. And finally, by creating a more resistant, lighter part to support a sustainable economy development. RVBs are a greener solution for green composites.
Silicones RVBs 101, why and how? What is needed to produce an RVB?
Transitioning to RVB process can be a simpler thing than some people imagine. Let's make a brief overview on what's necessary to produce an RVB. Before starting, take in account that the whole global R&D team from Elkem Silicones is willing to assist you on this process upgrade. The RVB will substitute all the disposables used in classical infusion process. This means that the plastic film, the resin channels, and the duct tape will be replaced by one cohesive mold, where the channels are previously sculpted. The RVB will be built over the rigid mold. In most cases, the inferior rigid mold currently in use is suitable to be used in the RVB process. Any rigid mold in the conventional infusion process with a side flange with a smooth free surface of around 10 centimeters is suitable for the manufacture of an RVB. Rigid molds from RTM and RTM Light can also be used, as long as the side flange characteristics are adequate. In order to produce the RVB, some materials are necessary. Most of them are reusable, and I'll divide them into groups: auxiliaries and silicone raw material. About auxiliaries, it's important to understand that, unlike classical infusion process, silicone RVBs will be produced copying the exact geometry of the piece and whatever is positioned above it. Practically, profiles are used to create permanent free spaces in the silicone bag, generating channels for the vacuum pump to remove the air and the resin to flow across the whole piece. These profiles are positioned only in the fabrication of the RVB, and they are removed just after the silicone cure, being reusable for future RVB productions. As the silicone cures, the format of the channels will be preserved, maintaining the open space that's necessary for a good resin flow. Once this channel is formed, through the whole life of the RVB molding, no more disposable channels will be needed, being one of the main sources of cost reduction. The vacuum channels are generally constructed from flexible square, trapezoidal, or semi-spherical profiles, with an area between 1 and 2 square centimeters. These are fixed on the side flange of the mold, and fixing can be done with the aid of double-sided tape. The chamber formed by these profiles guarantees the positioning and fixation of the mold during use. Vacuum and resin connectors are widely available in the market. There are options of metal connectors reinforced with cloth that provides to the final RVBs a quicker and more practical setup. It's also possible to produce, from the same silicone of the RVB, connectors to vacuum and resin tubing. This increases the cohesiveness of the mold, avoids tearing points, and reduces the total cost. Elkem RTV silicones can have a high elongation performance, reaching up to 500% of elongation. This is an important property on the demolding and prevents tearing. On the other hand, the mold borders and channels have a better performance with a more rigid profile. This guarantees that the positioning will be maintained and the setup time will not be augmented. Now, regarding the channels, rigidity will prevent them from collapsing, keeping them open for the resin to flow. To increase rigidity, reinforcement cloths are positioned in the silicone matrix, between the layers of silicone. This cloth will fortify the selected areas, keeping the high elongation only where it's the most important. For bigger molds and bigger molds only, it's possible, yet optional, to have lifting clips built into the RVB. These metal clips are well known in the industry and help moving the RVB around. The RVB will be made above the inferior rigid mold and a correct composite parting position. This will create the desired space to be fitted by the resin during infusion. The final silicone RVB will be a flexible and mechanically resistant mold that's easily moved and positioned. The rubbery aspect of the silicone is ideal to create the vacuum between the RVB and the rigid mold. All this, summed up with fast connection of resin and vacuum, results in one of the fastest mold setups. With a perfect fitted RVB, the infusion process is going to be as fast as in the classical infusion. The vacuum forces the resin to flow inside the fiberglass mesh, avoids air bubble formation, and fulfill the whole piece. After resin curing, the RVB can be demolded as the silicone has a natural property of easy release. Through the reproductivity capacity of silicone molds, composite parts produced by RVB infusion process tends to have a higher fiber-resin ratio, which increases the overall mechanical properties and may reduce resin consumption. It's necessary to highlight here how no disposables related to the infusion process are necessary. The total setup time is drastically lower when compared to classical infusion. Aligned with disposables reduction, these are the main cost reduction factors.
Silicone RVBs 101, why and how? What does it take to switch to this production process? We understand that you probably have experience in composite molding, and most certainly is already using a traditional method to produce your composite goods. But let's have a look at the pros and cons of the molding processes.
What you probably do not know is that transitioning from a traditional molding process to RVB infusion molding is an easy process. And most of the time, the structure already in use is compatible with the RVB. Throughout the cycling life, RVB processes stands out by robustly reduced cost through man-hour saving in fast setups and low waste material generation. When applied in a serial production, RVB is the best choice, being a reliable and efficient process. By standardization through low mold maintenance, long mold life, quicker setup, or less effective parts.
Exactly. So when you're looking at the total cost of ownership, price of raw materials needed in your production, investments and operating costs overall, we can conclude that when calculating the long-term value of switching to RVB, the gain over time is too important to neglect. Customer experience have demonstrated this fact every time.
Yeah, switching technologies is generally related to high investment costs. In fact, for preparing a silicone RVB, we require some material and know-how. On the other hand, if you are already producing composites in a traditional method, you probably have some infrastructure that will be used in the RVB process. As an example, the inferior rigid mold used in monolamination, RTM or RTM light are suitable to switch to RTV if it has enough space in the lateral flange for the vacuum channels to be built on. Also, RTM light already uses a vacuum pump, which attends to the RVB method. As for the classical infusion process, it's important to emphasize that the infrastructure is almost similar to RVB. This is the smoothest transition among all methods. Inferior rigid mold, vacuum pump, resin mixing system are all the same for both classical infusion and RVB infusion. But the transition pays off. RVB infusion is a reliable production method, mainly by how repeatability and high productivity are achieved in the molding, and the total cost of the mold is diluted along mold cycles. The easy transition between classical infusion and RVB infusion shows abruptly faster setup times, in addition to drastic waste reduction.
Getting up to speed on silicone chemistry.
About the silicone, the term silicone comprises a large family of synthetic polymers made from silicone. Silicones can take various forms such as fluids, resins, and elastomers as in the molds. As an integrated silicone supplier, Elkem is able to guarantee the quality of its products from the extraction of the quartz until the final formulation of the silicone elastomer. Elkem RTB2 line for molds is formulated to create high-performance elastomers by polyaddition curing system. Being a synthetic polymer, silicone has advanced properties in thermal performance combined with high chemical resistance, maintaining its flexibility even in extreme temperatures. Our series of silicone were formulated keeping in mind the common RVB manufacturing process. Our RTV2 are fluids that are easy to apply and have a curing time adjusted, generating elastomers that are chemically resistant to the molding condition of composites to produce long-lasting molds.
Start with the right products and partners. Looking at the key properties of silicones, what they will bring to, we will highlight in several points here. So they bring lightweight, which is important when you're transporting an RVB in between moldings. Silicones are long-lasting. It takes time to wear them out. They are corrosion resistant and easy processing. You just need the right equipment to get your process correctly installed. And on top of that, they have excellent mechanical properties. With silicones, you always have the flexibility of shape. We're talking elastomers, so flexibility is one of the key features. And the fact that this solution is room temperature curing. There's no release of toxic substances working with silicones, and there is no need for sealing tapes in the RVB process with silicones.
Exactly. If you're looking for a ready-to-use option, Elkem probably have the right silicone solution. Our product line counts with slow and fast cure silicones, with a range coming from 3 minutes of working time, that's ideal for automatic dispensing machines, up to 60 minutes of working time. That's ideal for manual mixing and brushing. We also supply products with and without ixotropic agents, which is the increase of resistance to flow. This helps to create a thicker layer even in vertical areas of the mold, and guarantees that the RVB will have sufficient thickness, avoiding the weakening of the mold by a thinner, more fragile area. Elkem specialists have developed a complete range of silicone elastomers, the Blue Seal RTV series. Blue Seal silicones for infusion processes are two component materials where the A and B parts are mixed in a ratio of either 1:1 or 10:1. These RTVs are suitable for either spraying, which is indicated for larger molds, as well for brushing, which is indicated for smaller molds and more complex geometries. This mixture of A and B parts will occur at room temperature by polyadditional reaction, forming a flexible, mechanically and chemically resistant material. To increase cycling life, Elkem Silicones for infusion molding were developed to support our customers to have more and more economic process. One of the main causes of silicone mold failures is that the contact surface is impregnated by resin and develop a brittle aspect, tearing at the molding. To avoid such defect, Elkem RTV silicones have a high chemical resistance and self-repairing performance. This means that in order to fix a teared area in a long-used mold, the same silicone used in the RVB production is able to adhere to the cured surface and reach up to 65% of its original tensile strength. No repairing materials are necessary here. In the long term, more resistant silicone with the ability to be repaired means a greener and less wasteful process. In addition to the silicones, additives can be incorporated into the mixture, aiming to control the RVB construction process. Reusable additives are available to increase or decrease the cure speed, adjusting the working time and total cure time to the production needs. Additives for increasing thixotropy are also available, suiting the silicones to more complex geometries. These additives will be mixed in a small proportion with the A and B parts before cure.
Finally, some attention should be paid to automatic dispensing equipment. Resin and composite industries are no stranger to automatic dispensing and mixing equipment. There are several options of electric and pneumatic mixers, different proportions, usually with a static mixer that can be permanent or disposable. Elkem Silicones for infusion molding are designed to be assisted by such equipment. Some care must be taken to avoid cross-contamination. A disposable static mixer are the best option. In this case, Elkem silicone will be sprayed, and by its property of self-leveling, create a thin layer of silicone. Even though this process is faster, slow-cure silicones were developed to give operators enough time to be hand-mixed and brushed on. This is a more affordable process and produces the same quality molds. We recommend our partner, Silicone Composites, to guide you through the choice of the right dispensing equipment. We get to the conclusion.
This is surely a lot of information. So if this webinar opened your eyes for an RVB transition, coming from any traditional method of composite production, this is what you should expect from a production assisted by an RVB silicone. First, a long-lasting flexible mold that will be chemically resistant. Second, immediate cost saving by disposable spare or waste treatment. And third, setup time acceleration.
A greener and more sustainable process. Here we are talking about green solutions that leads us to circular economy. In this connection, we are open to discuss with you around a circular model to dispose of your used molds. And we can help you to start saving money with RVB. We from Elkem are willing to support your transition from a traditional composite manufacturer to a state-of-the-art reusable vacuum bags infusion molding. Elkem's ambition is to give composite molders the independency to create their own molds, supporting the construction of know-how.
For so, we have a worldwide team of silicone molding specialists that will help you choose which silicone is a better fit for your production, and how to produce an RVB that will extract the maximum value from what a greener, cost-effective composite production can give.
Thank you for your attention. We get
Thank you.
some answers.
Thank you very much, Lisbeth and Mario, for this presentation. That was a really great presentation, really insightful. For your information, so we have some results about the polls. So we have more than half of the audience who know about RVBs. Only 15% of them use RVBs, and approximately 30% of the audience don't know about RVBs. So that gives you a little bit of background of our audience today. We started to receive some questions from the audience, and I would like to thank the participants for them. But I have some questions on my side that I would like to ask you before we start taking the questions from the audience. My first question for you would be, if I produce just a few parts of each model every year, can I use RVB?
I'll take this one, Lisbeth. Yes, you can. In fact, the silicone molds are stable in the long run. If you're willing to wait for the payback to not happen in just a few weeks or months, the silicone RVB can be restored by years in a row, without any more deterioration by time. We just suggest to store the RVB over the rigid mold to not create fault marks.
Okay, thank you. I have another question. How can I contact a salesperson in my region?
Okay, I will take this one, Mario. You can go to our website, so silicones.elkem.com, and there will be a formula that you can fill in. This will go automatically to the salesperson closest to you, who can reach you then by mail or by telephone. Or otherwise, you can always contact Mario and I through LinkedIn or the mail addresses in the presentation, and we will be happy to answer your questions.
Okay, great. So if you are interested in RVBs, you have the contact of Lisbeth and Mario on screen, so don't hesitate to drop them an email. My next question would be, can I start producing bags without dispensing machinery?
I'll take this one. Yes, you can. As Lisbeth pointed, our silicone have options for brushing. This is in fact a slow cure silicone. For a small amount of molds or molds with complex geometries, it's more indicated to apply silicone with brushes or even spatula.
Thank you, Mario. Another question, is it possible to make bigger parts with RVB?
Yes, I'll take this one also. Technically, any molding made by classical infusion is able to change it for RVB infusion. There are some challenges for bigger molds, as the silicone RVB will be made in only one piece. And higher weight, it's a little bit more difficult to movement. And sometimes there is need to machines for movement. All this should be considered in the project.
Right. Thank you. The next question would be, how should I store the silicone mold?
We recommend to store the silicone over the rigid mold when it's not in production. When it's in production, you can roll over the RVB, as it's a flexible polymer, and this also facilitates the positioning.
Okay. And how can Elkem help me dispose the silicone mold I used?
I will answer this one, Mario. When it comes to dispose the mold to be disposed, I think the best thing is that we have a discussion. You can count on us to try to help you to dispose it correctly. So we need to have a discussion and talk about what kind of needs you have, the consumption of silicone and so on.
Okay. And how much silicone is necessary to produce an RVB?
I can take this one. Also, there is a question from Nakshay Mali about the thickness, and it's about the same question. From our experience, we recommend 7 kg, 7 kilos of silicone for every square meter. This will generate a thickness around 6 millimeters. It's a good thickness to be resistant for higher number of cycles, and without losing its ability of flexibility and being too heavy.
Thank you, Mario. I have one last question before the one from the audience. Is RVB suitable for prepreg application?
Yes, it is. In the Prepreg, there's a step in the production of compacting, and it's possible to be made by vacuum. So silicone RVBs can be a solution for this one. There is actually a strength from silicone RVBs that is a thermal-resistant material, so it can join the piece in the oven to be submitted to temperature, and it will not be affected by temperatures under 200 Celsius degrees.
Thank you, Mario and Lisbeth, for answering my question. So we do have questions from the audience. So if you go on the question tab on the right of your screen, you can see the question appearing. Maybe you could answer a few of them that you can pick from the question tab.
Okay, I see one question here about the temperature resistance of the silicone. In general, we can go for 200 Celsius degrees. It's a good temperature, but temperature is not the only aspect we should consider, because resins have a chemical attack on every surface, the rigid mode and the RVB mode. So temperature plus this chemical attack should be considered and verified. It's hard to say which temperature we can guarantee the silicone will support when it's always in contact with a different resin. So don't hesitate to contact me, and we can check for your specific resin that you're using in your production, how resistant our silicone is.
I see a question. Do you make tools from silicone? We don't make tools. We make the silicone. So if there is some, if the question could be broadened, perhaps we could be more helpful on this one.
Yeah, Elkem has an expertise of silicone formulation, fabrication, and supply. So our best game is on silicone chemistry, but we do have some partners that may help you in your needs.
There is a question on how many times silicone vacuum bags can be reused. It really depends on the resins you're using in your production. But as we've given some examples during the presentation, and also what should be the lowest number of molds to make before it should be financial viable. I think this is a good guideline. Otherwise, we should talk more precisely about what kind of resins you're using together with in your production.
Stefan asked us about the shore hardness of our products. Specifically on the Infusion silicone line, we have shore from 20 to 30. So all of our products are in this range. But in our whole line of RTVs, we have silicones lower than 1 shore, so 0.0 shore, to I believe 60 shore. So you can, from our experience, this range from 20 to 30 is the best performance.
Any other questions you can take from the audience right now? Otherwise, I remind the audience that Lisbeth and Mario will get back to you by email if they don't answer your question live during the session, so don't worry.
Yeah, we will definitely get back to each of these questions to all of the attendants for sure.
Let me just answer one more from Martin. It's about the epox attack on the silicone surface, and if it's possible to use any silicones to protect the surface. From our experience, our silicone has a really good chemical resistance, but it changes from resin to resin. And yes, epoxy is one of the most aggressive resins to polymers. Both the silicone resin, the silicone RVB, and the rigid mold that's made from other resins. From our slide about the self-repair, our silicone has the ability to adhere to itself. So a cured surface that's already attacked and has a more brittle aspect can be covered with silicone RTV of the same line that was produced at the RVB. But we should be careful to not lose the fit of the mold as you are aggregating new layers of silicone.
All right. Thank you, Lisbeth and Mario, for this presentation and for answering my questions as well as some of the audience. So again, Lisbeth and Mario will get back to you if we didn't answer your questions during the session. I would like to thank all our attendees. If you have any other questions or need information about Elkem Silicones and how to lower your production cost in composite molding, you have Lisbeth and Mario's contact on the slide, so don't hesitate to drop them a line. This webinar has been recorded, so you will be able to view the entire program online on jecomposites.tv. We appreciate everyone's participation today, and we hope to see you again at next JEC Composite webinar. Thank you, Mario. Thank you, Lisbeth. Have a great day, everybody, and see you soon.
Thank you.
Thank you very much.
Bye-bye.
Bye.
Bye.